Yeah. So yesterday I discussed about PDCP overview and then RLC and MAC layer services and functions, and as well as their formats, PDO formats. Okay. And I just said what is RRC. So let me have a discussion today about the RRC. Okay. Is that fine? Hello? Hello, can I get the response?
Yes, sir.
Yeah, just as a reminder, whoever is there, they're all attentive, I feel, because only Shreyas is responding, others are not. So don't take it other way. Just since it is semester ending now, I am finding the involvement of the people is already gone. Hmm? So even yesterday afternoon, I had very few students. Today also not much, 50% only. So just I am giving the Abdul Kalamji statement. So without your involvement, you cannot succeed. With your involvement, you cannot fail. Okay, since you are all in the 8th semester, result is very crucial, right? So you have to be involved in learning this subject, and you have to clear it, because you all know the exams will be offline. Okay, so take it in a positive spirit and try to read, understand any difficulty at any point of time. I am there to clarify, to supply material. Okay, so but your involvement is required. Okay, so with this one word from my side, so let me start about the RRC. Okay, so as I said yesterday, the RRC layer, that is a radio resource control, right, or connection layer, takes care of RRC connection management, radio bearer control, mobility functions, and user equipment measurement, reporting and control. Okay, then broadcasting system information and phasing. So these are all the functions carried out by the RRC layer. So in that, first one is the RRC states. So yesterday what I said, these are the two states in the LTE has. One is RRC idle state and another one is RRC connected. Okay, so when do we say it is in idle state and when do we say it is in connected state, right? So this RRC states simplifies the machine handling and the radio resource management, which controls the RRC state. So when the user equipment is in the RRC connected state, so when an RRC connection has been established, okay, when an RRC connection has been established, then we say the user equipment is in the RRC connected state. Otherwise, the user equipment is in the RRC idle state. Okay, so these are the two states of RRC which uses in the LTE. Okay, I repeat once again, to say the user equipment is in the RRC connected state when an RRC connection has been established. Otherwise, we say the user equipment is in the RRC idle state. So let us try to understand what is this RRC state in LTE. Hope you able to visualize this diagram. RRC idle state, then RRC connected, like on and off. Okay, on state is the RRC connected and off state is the RRC idle. So it is like a Markovian chain process. Okay, so connection establishment and connection release. From idle state, when it is going to the RRC connected state, then we say the connection has been established. Okay, and when it releases the connection, then we say it is moving from connected state to idle state, right? So the user equipment controlled mobility. Means under RRC idle, what I can say, all these things will happen. Okay, UV controlled mobility, that is about the cell selection and reselection, phasing, broadcast of system information, then unicast data transfer, network controlled mobility, that we say handover. Okay, I think I repeated again. Yeah, means under RRC idle. Okay, so these things will happen, and under when RRC is connected, so these things can happen. Unique as data transfer, network controlled mobility, phasing, broadcast of system information. So, what is RRC idle state? Okay, the user equipment can receive broadcasts of system information and phasing information. So that is why it is written phasing broadcast of system information under RRC idle state. Okay, so there is no signaling radio bearer established, so there is no RRC connection. The mobility control is handled by the user equipment, and it performs neighboring cell measurements and as well as the cell selection or reselection. So the system information contains parameters by which e-neutron controls the cell selection or reselection process, such as priorities of different frequencies. Okay, so the user equipment have been allocated an ID that uniquely identifies the user equipment in a tracking area. The user equipment monitors a phasing channel to detect the incoming calls, and it specifies the phasing discontinuous reception cycle, so DRX cycle. So this is what is happening in RRC idle state. Okay. And in RRC connected state, the user equipment has an e-neutron RRC connection. So I hope you will be able to visualize what e-neutron is. That is ENBs. Okay, that network we call as e-neutron, right? So the user equipment has an e-neutron RRC connection and a context in the e-neutron. So it is able to transmit and receive data from the network. Okay. When it is in the RRC connected state, the user equipment is able to transmit and receive data to or from the network. So the user equipment monitors control channels like physical downlink control channel associated with the shared data channel, that is SDCH we say, to determine whether the data is scheduled for it or not. The user equipment can also support channel quality information, and as well as it can provide feedback information to the eNode B to assist the data transmission, and the network control mobility or handover of the user equipment can happen. Okay, so user equipments provides neighboring cell measurement information also. Okay, means what is the neighbor cell signal strength and other things. It will be giving that information to the eNode B so that it can take the handover decision. Okay, so these are all the actions or things happening in the RRC connected state. Yes, hope these two things are clear: RRC idle state and RRC connected state. Then RRC functions. Okay, so in that, first one is signaling radio bearers. In short, we call SRBs. Okay, so here the radio bearers that are used only for the transmission of RRC and the NAS messages. Okay, so here there are three different types of SRBs in LTE. One is SRB 0. So SRB means signaling radio bearers. Okay, so this LTE has three different types of SRBs. One is SRB 0. It conveys RRC messages using the common control channel. Then SRB 1 is the RRC messages and NAS messages prior to the establishment of SRB 2, all using the downlink control channel as a logical channel. Okay, then SRB 2 uses NAS messages using the downlink control channel as a logical channel. So SRB2 has the lower priority than the SRB1 and is always configured by the EUtron after security activation. So these are the three different types of SRB signals in LTE. Okay. Yeah. Then what are the main functions of the RRC protocol? So first thing is broadcast of system information. So what is the system information? It has two things. One is master information block that we call in short as MIB, and the second one is the system information blocks. So that is SIBs. Okay. So this is the information which is going to be broadcasted. MIB and SIB, master information block and system information block. So what is this master information block? So this MIB is a what limited number of the most essential and most frequently transmitted parameters, okay, that are needed to acquire other information from the cell and is transmitted on the BCH logical channel. That is what is the MIB. And SIB, that is system information blocks, other than SIB type 1, are carried in the system information messages, SI messages. So let us see that is what is further things. So SIB type 1. So what I said here, SIBs other than SIB type 1 are carried in system information messages. So here what is that SIB type 1 is told. So SIB type 1 contains parameters needed to determine if a cell is suitable for cell selection, as well as the information about the time domain scheduling of the other SIBs. Okay. So SIB type 1 and all SI messages are transmitted on the downlink shared channels. Okay, so what is the RRC connection control? Means what is the procedure which is related to that? So this RRC connection control procedures related to the establishment, modification, and release of an RRC connection. Okay, then phasing, initial security activation, establishment of SRBs, radio bearers carrying user data, radio configuration control, and quality of service control, and as well as the recovery from the radio link failure. So this is what the RRC connection control procedure related to these functionalities. Okay, establishment, modification, release of an RRC connection, phasing, initial security activation, establishment of SRBs, radio bearers carrying user data, radio configuration control, quality of service control, and recovery from the radio link failure. Yeah. To discuss about this measurement, configuration, and reporting, that deals about the establishment, modification, release of measurements, configuration, and activation or deactivation of measurement gaps, then measurement reporting, intra-frequency, interfrequency, and inter-RAT, that is radio access technology, inter-RAT mobility. So all these are the measurement configurations and what data it is going to report to the ENB. Other than these, other functions are related to that are the transfer of dedicated NAS information and non-3GPP dedicated information. Okay, and as well as the transfer of user equipment radio access capability information and support of self-configuration and self-optimization. Okay, so this is all about the RRC, what I can say. Okay, then about when we come to this mobility management, okay, in short, we call this as MM. Okay, see, mobility management functions can be categorized into two groups. Okay, one is the mobility within the LTE system, that we call it as intra LTE mobility. Okay, another one is within other system. Okay, mobility within the LTE system, that we call it as what? Intra LTE mobility, and mobility with the other LTE system, means other system, that is what? Inter mobility we say, right? So this can happen over the S1 interface or over the X2 interface. So hope what is the S1 interface? This is the interface between what? Yes, any one of you, is it possible to say quickly? S1 and X2 interface. What is the X2 interface used for communicating between what nodes? Any idea? X2 interface. See, X2 interface is used to communicate between different ENBs, right? From one E node B to another E node B. So they are communicating over this interface. That interface name is known as X2. And S1 is from E node B to the serving gateway. Okay. So that is the S1 interface. Okay. So when the user equipment moves from one E node B to another E node B, right, within the same radio access network attached to the same mobility management entity, then the mobility takes place over the X2 interface. Okay. I hope, I think I have told when with the clear-cut diagram when I was telling about the architecture. Okay. Uh, so how many E node Bs will be controlled by one serving gateway and as well as one mobility management entity? Then how that will be replicated and it will be controlled by a different serving gateway, and how the mobility management entities can communicate each other. Okay, and what is the interface for that also? So with respect to that, what I said, when do we say the mobility takes place over the X2 interface? When the user equipment moves from one E node B to another E node B within the same radio access network attached to the same mobility management entity. Okay, you can visualize that some 3-4 ENBs are there. Okay, those 3-4 ENBs are in turn is connected to one serving gateway and as well as one mobility management entity. So in that case, the mobility management, this mobility takes place over the X2 interface. So other thing is when the user equipment moves from one ENB to another ENB, that belongs to the different radio access network attached to different mobility management entity. Okay. So hope you are able to visualize that. If two ENBs are comes under a single radio access network, right? In that case, the mobility takes place over the interface known as X2. And when the user equipment is moving from one ENB to another ENB, and those two ENBs are under different radio access networks, okay, and they are attached to different MMEs, then the mobility will take over the S1 interface. Okay. Yes, got this idea? Yes, my dear students, are you able to get that visualization? What I said. Let us assume 4 or 5 ENBs are connected to one serving gateway, and in turn it is connected to one mobility management entity. In that case, if the user equipment is moving from one ENB to another ENB, and those two ENBs are under a single radio access network and those are attached to the same mobility management entity, then we say the mobility takes place over the X2 interface. Okay. So when the user equipment is moving from one ENB to another ENB, and that ENB belongs to another radio access network, which is attached to another mobility management entity, then the mobility takes place over the S1 interface. Okay. Yeah. So mobility to other systems means this is one is within the LTE system, right? Mobility within the LTE system that we call as intra LTE mobility. So can happen with these two interfaces. One is over S1 interface, another one is over X2 interface. I told when it will happen over X2 interface And when do we say it is happening over the S1 interface? Then with other systems, like along with the LTE 4G system, even 3G, 2G is also existing, right? So with that, how that mobility happens? So 3G PP system, example UMTS, and non-3G PP systems like inter-RAT mobility, we say, right? So the inter-RAT mobility uses the S1 mobility within the with the only difference being that in this case the PDCP context is not continued and the user equipment needs to re-establish its session once it moves to the target non-LTE system. So this we will be able to understand with the flow diagram. So let us try to take that. uh, First let me say about the S1 and X2 interface, then we'll see that. So S1 mobility, as I said, it happens when the user equipment is moving from one ENB to another ENB, and those two ENBs are in different radio access networks under different mobility management entities, right? So let us see this how, what is the preparation phase and all. So this S1 mobility consists of three steps. Okay, first one we called as a preparation phase. Okay, what is that preparation phase? So in the preparation phase, once the decision has been made for the handover and the target mobility management entity and E node B have been identified, means over what ENB under which comes under which MME the handover need to be made. Once the decision has been made, so what happens? The network needs to allocate the resources on the target side for the impending handover. Okay, so the mobility management entity sends the handover request to the target E node B, requesting it to set up the appropriate resources for the user equipment. So all these things happens in a fraction of microseconds. Okay, but we need to say what is the procedure. So that is, this is what the preparation phase, what we say. What I said, once a decision has been made for a handover and a target MME and E node B have been identified, then the network needs to allocate the resources on the target side for the impending handover, right? So the mobility management entity sends a handover request to the target E node B, requesting it to set up the appropriate resources for the user equipment. Then once the resources have been allocated at the target E node B, it will send the handover request acknowledgement to the mobility management entity. So once that message is received by the mobility management entity, then it sends the handover command to the user equipment via the resource E node B. Okay, so this is what about the preparation phase. So which is shown with the flow diagram. So this is important. Actually, many times they're asking. So out of these two, any one question will be there, either S1 mobility or X2 interface. Okay. So that is what try to understand this flow diagram. So this is your user equipment. So this is going to experience a request for the handover, right? And this user equipment is under this E node B. So that we call as source E node B. Then this is the target E node B. Then this is the source mobility management entity and target mobility management entity. So under source ENB, there will be source MME. Under target E node B, there will be target MME, right? Or vice versa, you can say, means under this target MME, the target E node will be connected. The source MME, the source E node will be connected. So the user equipment will be sending the report to the E node B, right? So E node B will be having the information from user equipment that okay, it requires an handover. So the source E node B will be sending the handover request to the source mobility management entity. Okay, so that is the first information, first step what I can say. So E node B will be sending the handover request to the mobility management entity, the source MME, to the source MME, right? So this source MME will be forwarding that allocation request, resource allocation request to the target MME. So MME will communicate to the MME. Okay. Then, so this is happening in the preparation phase. So there are 3 steps. Okay. Just now I said only first step, that is a preparation phase. So what target MME will do? It will find out the nearest E node B, right? And it will say the resource is set up. Means it will find out the E node B, nearest E node B, and it will uh, provide the resources, and it will say, yes, I can give the resources. Means that information will be intimated to the target E node B, resource setup. Okay. And this target E node B will be acknowledging the target MME that, yes, I can provide a service to that particular user equipment. Means I have a resources, I can provide that. So that is what the handover request acknowledgement. So this is what I said in the preparation phase. The next phase is the executive phase. Okay, so what happens in executive phase? So once the target MME gets the acknowledgement, handover request acknowledgement from the target E node B, then the target MME will be forwarding the reallocation response to the source MME. Okay, in turn, the source MME, what happens? It will be sending an handover command to the source E node B. Okay, in turn, this source ENB sends a command to the user equipment. That what command? That is handover command. Means, yes, I can provide or change over the connection to other ENB, like that, right? Then the user equipment, that RACH access will happen. Okay, means the source E node B will be sending the status buffer to the source MME. Okay, then the target MME will be sending that MME status buffer to target E node B. Then, so the user equipment will confirm about the allocation of the resources to it by sending handover confirm message to the target E node B. Then the target E node B will notify the target MME about that handover. Okay. Then it will acknowledge whatever that has been sent, forward reallocation complete message to the source MME. Then uh, okay, then what happens? The source MME will release the resources which are used by that particular user equipment from the source E node B. Okay, so this is the what completion phase. So these are the 3 different phases which are happening in the mobility. It is very simple to understand with this flow diagram. What I said in the preparation phase, so the user equipment will be transmitting its uh, parameters, means its signal strength and other things to the source ENB. So based on that, source ENB can take a decision. Okay, well, this user equipment is moving, need a handover, so it will send the handover request to the source MME. Okay, source MME will forward that reallocation request to the target MME. Okay, so the target MME will request the target E node B about this resource setup. Okay, so the target E node B, once it finds that proper resources, then it will acknowledge to the target MME about the handover request acknowledgement. Then the target MME will be sending that forward reallocation response to the source MME. In turn, the source MME sends a handover command to the source E node B. Okay, then the source E node B will be sending the handover command to the user equipment saying that, yes, you can, resources will be allocated. Then that random access channel, by using that, it will be able to access different frequencies from the user equipment. So it will confirm, the user equipment will confirm about its handover to the target E node B. Then the target E node B will be notifying the target MME about the handover. Okay, then the target MME will send a forward reallocation complete message to the source MME. Then the source MME will send a release resources message to the source E node B to release the resources, whatever it has allocated to the user equipment earlier. So I think around 10 steps are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to 12. So for 10 marks, they will ask this flow diagram. Very easy way you can explain. So I think I need not tell what is this execution phase and what is the completion phase, which I have already explained. Right? So in execution phase, what is happening, I said? Yes, what is happening? Once the user equipment receives the handover command, it responds by performing the various radio access network related procedures needed for the handover, including accessing the target eNode B using this random access channel, right? So when the user equipment performs the handover, the source eNode B will initiate the status transfer where the PDCP context of the user equipment is transferred to the target eNode B. This is what is happening in the execution phase, and then the source eNode B will forward the data stored in the PDCP buffer to the target eNode B. So once the status and the data have been transferred to the target eNode B, the user equipment is able to establish the radio access bearer on the target eNode B, and it sends the handover confirm message to the target eNode B. So last step is the completion phase. Here, when the target eNode B receives the handover confirm message from the user equipment, so it sends the handover notify message to the target MME. Then the MME will inform the source ENB to release the resources originally used by the user equipment. Okay, so this is what the different steps involved in the S1 interface. So next one is X2. Okay, so what I said, X2 mobility happens when the user equipment is moving from one ENB to another ENB, and those two ENBs are in the same radio access network and the same mobility management entity, right? So as a first step here, what happens? The mobility over the X2 interface is the default mode of operation in LTE unless an X2 interface is not available between the source and the target eNode Bs. Okay, so the mobility over S1 interface is triggered as already we have discussed, right, how the mobility happens over the S1 interface. So let me just discuss with the flow diagram so it becomes easy rather than saying theoretical steps. So again, what are the things here will come? User equipment, source eNode B, target eNode B, then mobility management and serving gateway. So you should be able to get the difference between this flow diagram, which is under X2 mobility, and the flow diagram what I have shown for S1 interface. So in S1 interface, source eNode B, then source MME was there, right? Similarly, the target eNode B and the target MME was there because eNodes are in the different radio access network, which comes under different MMEs. But in this case, in case of X2 mobility interface, both the ENBs are under the same MME, right? Are under the same radio access network. Hence, here only the shown source eNode B and target eNode B under one MME only, right? Okay, so as usual, the first step is the source ENB will be sending the handover request to the target ENB, right? Then the target ENB means in turn it will forward to the MME, right? Means the resource setup will be done from the target eNode B. Okay, and it sends handover request acknowledgement to the source ENB. So first communication happens between these two ENBs only, right? So source ENB will be sending the handover request to target ENB. The resources will be setting up by the target ENB. Then it sends an acknowledgement message to the source ENB about the handover request. Then the source ENB will be send the handover command message to the user equipment saying that yes, I am ready to hand over the channels. Then the source ENB will be transferring about the inode B status transfer information to target ENB. So through RACH access, it is through random access channel, the user equipment will be confirming about the handover to the target ENB. Okay, then the target ENB will send the information to the MME, which comes under the serving gateway, about this path switch request. Means there will be changeover of the channels, right? Frequencies. Then the MME will acknowledge for this path switch request message by saying path switch request acknowledgement. Then the target eNode B will be sending the release resource message to the source eNode B after handing over the resources to the user equipment to release the earlier allocated resources. So that is what in the completion phase. Okay, so we say preparation phase, executive phase, and completion phase. So 3 steps under every interface. So that is what is written here, mobility over the X2 interface. As said, 3 steps. One is the preparation phase, right? So what happens in the preparation phase? So once the handover decision has been made by the source eNode B, it will send the handover request message to the target eNode B. So that is the first step, right? Then what the target eNode B will be doing? So upon receiving that message, right, from the source ENB, it will work out about the availability of radio resources with the MME and serving gateway to set up the resources for the user equipment. Then it is possible to set up the resources on a per RAB basis. Then it will, that which implies that upon completion of the handover, the user equipment will have the same RABs at the target eNode B with the same set of quality of service as it had on the source eNode B. Okay, then that process makes the handover quick and seamless, and the user equipment is not required to set up the RAB with the target ENB once handover is completed. So then the target ENB responds to the source ENB with the handover request acknowledgement once it is ready. So that is what in the preparation phase. Then in the execution phase, what happens upon receiving this handover request acknowledgement, the source ENB sends handover command to the user equipment, right? So when the user equipment completes the RAN related handover procedure, then source ENB starts the status and data transfer to the target eNode B. So that is done on per RAB basis for the user equipment. Then the last is the completion phase. So here, once the user equipment completes that handover procedure, it sends handoff complete message to the target eNode B. Then the target eNode B sends this message. What is that? Path switch request to the mobility management entity or serving gateway, and the serving gateway switches the GTP tunnel from the source eNode B to the target eNode B. So when the data path is the user plane is switched, then the target eNode B sends a message to the source eNode B to release the resources originally used by the user equipment. So the source eNode B can select the lossless handover for one or more of the RABs. Both the PDCP processed and PDCP unprocessed packets are sent to the target eNode B during the status buffer. So the PDCP processed packets are the data packets that have been transmitted by the source eNode B to the user equipment, but the user equipment has not yet acknowledged the receipts of such packets. So PDCP unprocessed packets are the packets buffered by the PDCP layer that are yet to be transmitted by the source eNode B. So this is what the difference between processed packets and unprocessed packets of PDCP. Okay, so PDCP processed packets are the data packets that have been transmitted by the source eNode B to the user equipment, but the user equipment has not yet acknowledged the receipts of such packets. That is known as PDCP processed packets, and unprocessed packets are the packets buffered by the PDCP layer that are yet to be transmitted by the source eNode B. So in LTE, So there is an additional feature known as selective retransmission, so which is enabled when the target eNode B may not retransmit the PDCP processor packets that were forwarded but were acknowledged by the user equipment after the status transfer was initiated. Okay, so that is one special feature of LTE. It has the selective retransmission, so which will be enabled where the target eNode B may not retransmit the PDCP processor packets that were forwarded but were acknowledged by the user equipment after the status transfer was initiated. So this is what about the X2 mobility. So as I said, out of these two, definitely there will be one question on this topic for 10 marks. So if you are thorough with the flow diagram, I hope you will be able to uh, say in your own words what is happening, how handover takes place, right? So then you don't have to be so specific about the technical terms which I told at some places. I think with this flow diagram, I think you should be able to say. Only with the S1 interface, you should have in mind it is between two ENBs, which comes under two different RANs. They are there under two different MMEs. Okay, X2 interface. The mobility over X2 interface happens when two ENBs are under the same RAN. Okay, that is the only difference. And if that is the case, in what way the messages have been exchanged between different nodes, that is important. Okay, yeah, next one is I think phasing. Okay, I will take up this phasing, I think, in the next class. So at least I want you people to practice this S1 and X2 mobility properly. Yes, can I expect a 5 minutes discussion about this from your end? Yes, my dear students. Whoever is there, yes, please can come forward and say with your understanding. Just with respect to block diagram, and this flow diagram only I will ask. I will give the flow diagram and I want you people to say. Yes, who can say about this? This is about the handover with S1 interface. Yes, Anup, can you brief, man? Anup. Hello, Anup. No, what about Ritika? Yes, Ritika.
Yes, sir.
Yeah, just can you say your understanding about this mobility over the S1 interface? I have shown the flow diagram also there. Just
Yes,
is it
sir.
possible to say in your own words how it happens? Yes, Ritika, can you say?
Sir, I don't know.
Means you are not there with me. Yes, you are not there.
I'm there, sir.
So then what you have understood? It is very simple now. So it has three phases. Yes, anybody, other people? Before I say once again. Yes, who can say? Means whoever was attentive, I think they will be. Yes, what about Saujanya?
Sir,
Can you say your understanding about this S1 mobility over the S1 interface?
check.
Yes.
About the request, how handover request and then confirmation.
Before that, you need to say, see, user equipment will be keep informing the source ENB about its signal strengths, right?
Yes, sir.
And then, yeah, so it is the handover of resources to the user equipment who is moving from one ENB to another ENB, and those two ENBs are under different radio access network and under different mobility management entities. Yeah.
Will be handed over, using that one handover, and then X2 interface will not be available between the source and target of E node B.
Okay. Yes, sir. Yeah, that's. Hmm.
That's what says. Then using F1 handover,
Yeah.
if the X2 interface is not available between the source and target E node,
Hmm.
next whatever the message interactions will be involved between the E node B,
Hmm.
that was done using the time of handover.
Okay. Okay. At least for others, tomorrow again I have first hour now. I will spend 5 to 10 minutes for these two, S1 and X2 interface. So I expect you people to go through this, and we should be able to say Ritika, Anup did not talk, and others also, whoever is there. Okay.
Sir, I had got a call, sir, so couldn't answer. Sorry, sir.
Fine. At least tomorrow you should answer, man. S1
Yes,
and
sir.
X2 interface. Okay.
Yes, sir. Will answer, sir.
So with this, let me stop today.